Okay, so I'm going to start off the lesson by reviewing scatterplots. So here I've got a set of data, and it's obviously bivariate data, temperature in degrees Celsius versus ice cream sales in dollars. Now, when you input data into your spreadsheet, it's really important that you label your columns. And the way I want you to label from now on is to actually put down the X and Y variables into those columns. So I'll give you an example. Now, clearly, we know that temperature will affect ice cream sales, but not the other way around. So temperature is clearly our explanatory variable X. So when I label my X variable, I will start off with X, and then I'll just say it's temperature. And then for the second column, ice cream being my Y, I'll start off with Y, and then just put my ice cream sales. This way, when you go and do other things with this data, you will always know that the temperature is your X and the sales is your Y, without even having to think about it. Okay, so the first thing we'd like to do is to create a scatter plot. So you go into your main page and you go find your purple icon. And obviously, when you click to add variable, you add the X on the X and the Y on the Y. See how easy it is? You don't even have to think about it, okay? One less thing for you to worry about. And when the data is plotted onto a scatter plot, we often like to describe the scatter plot. And there's three things that we'd like to know about it, or would like to describe. Form is one. Direction is another, and also the strength. Okay, so form, in further maths, all we care about is whether it's linear or non-linear. In this case, it's pretty linear, so you just say that it's a linear relationship. In terms of direction, because it's going up like that, we know that it is a positive relationship, and positive, we don't just use positive for the fun of it. Positive actually means that as the X variable, temperature increases, the Y variable, or the ice cream sales, will also increase. Okay, that's how you would interpret a positive relationship. Now, if the relationship was going in the opposite direction, so negative, it means that as X increases, Y decreases. So please make sure you understand that. Now, the other thing we want to know about the relationship between these two variables is also how strongly related they are. Now, you can look at it and you can make an interpretation, but the best way to decide on the strength of the relationship is to find Pearsons correlation. Okay, Pearsons correlation is your R value. Okay, so to do that, we'll go back to our spreadsheet. Oh, I don't even know why that's there. Delete. Okay, go back to our spreadsheet, and what we want to do is we want to press menu, and it's 4, 1, 3, linear regression, mx plus b. Now, as soon as you click on it, it's really easy. The X will be your X and the Y will be your Y. No thinking involved. Just double check that the results column will appear on an empty column, because you don't want to override your data. And then just press OK. So here we go, and our R is right there. Our Pearsons value is 0.9579. Let's round it to two significant figures and give it as 0.96. Okay, now you should all in your summary books have the charts which describe what Pearson actually means, or like describe what each value actually means. So 0.96 is actually a very strong correlation or relationship. So strong correlation or relationship, or we can call it an association. Okay, now that's what Pearson's for. So when you're describing the strength, you would just say that it is strong. So when you're describing that scatter plot that you saw just before, this one, you would actually describe it as a strong, positive, linear association or linear relationship. Okay? And you use Pearsons to describe the strength of relationship. Now, the other important thing about that function that we used before is not just the R, but also the R squared value. That is the coefficient of determination. Okay, I call that just COD. That's your R squared value. And our R-squared value, as you can see here, if I round it to two significant figures, that's 0.92. Okay, now how do we interpret the R-squared value is this. Remember this sentence, okay? It's in your notes as well, so all you have to do is replace the variables. And I would say, I would convert the decimal into a percentage, and I'd say 92% of the variation in the the ice cream sales can be explained by the variation in temperature. So basically what you're saying is that 92% of variation in the y variable can be explained by the variation in the x variable. Okay? So if it was another question, all you would do is replace the percentage and then the x and y variables as per this layout. And then you'd say 8% is due to other factors. Basically what you're saying is that 92% of the time, the reason for those ice cream sales is because of the temperature. Okay, 92% of the time, it's purely due to what the temperature is. 8%, okay, is due to other factors other than the temperature. Okay, so that's how you interpret the coefficient of determination. Okay, I'll leave this one as that. Ooh.